All right, students, so some of you wanted me to make a video on some of the Deltamath problems from Unit 3, specifically the angle sum problems, the triangle angle sum problems, and the exterior angle problems. So here we go. This is the first one that popped up, and it's just a triangle problem. Let's read it together. What's it say? It says, in triangle BCD, measure of angle B is 7x plus 12 degrees. Measure of angle C is 2x plus 13 degrees, and the measure of angle D is 2x plus 12 degrees. And we want to find the measure of angle D. So let's go ahead and draw the picture. Again, in geometry, it always helps to draw the diagram. So here's triangle BCD, and 7x plus 12 is this angle B. And so that's the amount of turn between these two line segments. So if we think about it as a circle is 360 degrees, how far is it going from here to here in degrees? That's what we're going to see if we can figure out. And actually we're looking for this angle down here, which is the measure of angle D. So these are the algebraic expressions that relate to all of the angles. And is this an interior or exterior angle problem? Well, they haven't given us any exterior angles, so it must be an interior angle problem. So let's take a look. How do we find the sum of the angles of a triangle? Well, remember when we created these triangles and then we tore them apart and then we flipped up, say, angle A and angle B, and they formed a straight line. So that's how we learned about the angle sum of a triangle equaling 180 degrees, or it's half a circle, which is 180. 360 is a full circle, and half a circle is 180. So let's use that angle sum theorem to figure out this problem. If I add up all of the angles, I know they have to equal 180 degrees. So that's what I'm going to do. There are my three algebraic expressions. I'm just going to combine them, set them equal to 180 degrees. Now I need to combine like terms. That's why I put squares around the x terms and, well, circles or ellipses around these constants. If I combine them, I get 11x plus 37 equals 180. Now I'm going to subtract 37 from both sides, which leaves me 11x equals 143. If I divide both sides by 11, I get x equals 13. Yes, I'm done. Oh wait, let me read the problem again. Oh, I need to find the measure of angle D. And that's this algebraic expression here. So what do I need to do? Plug in 13 for x right here. So the measure of angle D is 2 times 13 plus 12, or 26 plus 12, which is 38 degrees. And then you can go in and actually plug in all of the other ones and figure out, and just to double check to make sure that your angle sum equals 180 degrees. But you can do that on your own, so when you pause the video and check that, make sure I did my work correctly. Let's take a look at an exterior angle problem now, though. All right, so here is an exterior angle problem, and I like the purple. It's pretty cool. So let's take a look. What's this say? So in triangle STU, SU is extended through point U to point V, and then it gives us all the measures of the angles that we need, and then we have to find the value of x. So I drew triangle STU, but now I need to extend SU through U to some point out here called V. So let's go ahead and do that. Now I've extended SU through U to point V. Now let's label the angles. So angle STU, which is this top angle up here, is 3x plus 13. Angle UST is x plus 20, so UST, that's this angle. Remember, the vertex always goes in the middle, and that's the vertex. And then lastly, the exterior angle, the angle on the outside, TUV. So that's this outside angle, is 7x minus 15. And what do we remember from the exterior angle theorem? The exterior angle theorem tells us that this outside angle, this exterior angle, equals the sum of the remote interior angles. So by remote, the non-adjacent angles. So not this one, these other two angles have to equal this one. And when we talked about that one, it's because we know the angle sum of a triangle is 180. These two angles are 180. So because this is in common in both of those, this angle here must equal these two. So let's take a look. 7x minus 15 equals 3x plus 13 plus x plus 20. So I'm just going to combine like terms again. And that's going to leave me with 7x minus 15 equals 4x plus 33. I'm going to subtract 4x from both sides. Leaves me with 3x minus 15 equals 33. Add 15 to both sides. Divide by 3, because 3x equals 48. Divide by 3, x equals 16. All right, and I didn't do this in the last problem, but how do I check this? I'm going to go ahead and plug in x for all of these expressions here and make sure everything works. So here we go. 7 times 16 minus 15, 3 times 16 plus 13, plus 16 plus 20. Do these equal each other? Yeah, so I'm just basically redoing this whole equation here and plugging in 16 for x, just to make sure I did all of my math correctly. And I get 97 equals 97. By the way, always go back and reread the question to make sure you found the correct answer. So in this case, I was looking for what the value of x is, and yeah, I found x equals 16. So it wasn't asking you for the angle measures, it was actually asking you for the value of x. So I hope this helps, and please let me know if you have any questions.